All right, everybody, welcome back. Glad you guys are here with me today. We are going to be talking about SR7, which is adding, subtracting, and simplifying radicals. Now, this is kind of the first of two review days as we start preparing you for your test on this radical stuff. We've been doing radicals for quite a while now, and obviously we had the break with spring break, so now we got to come back and pull all those skills together. So looking here at problem number one, remember the prime way that we break down radicals and simplify them is by using a factor tree. 12 is 4 times 3, 4 is 2 times 2, and then 2, 2, 3 would be the prime factors of 12. So when I come over here, I can rewrite this as 2 times 2 times 3. And then since I had x squared, we're going to write x inside. Now the way this works is we are going to look for any pairs that we have. We have two 2's, so we're going to pull out a 2. And we have two x's, so we can pull out an x. We call that our 2-for-1 special. Once you do that, you can cross out the terms that you pulled out. So on the outside, I have a 2 in the x. And then on the inside, we still had a 3 inside. So this is 2x square roots of 3. Let's take a look at the next one. This one is 150. 150 is 50 times 3. 50 is 25 times 2, 25 is 5 times 5. So I can rewrite the square root of 150 as 5, 5, 2, 3. Again, taking each of the prime factors that multiply to be it. Do your 2-for-1 special, pull it out, you're going to have 5. Now inside you notice you have two numbers left here. That's not 23, that's 2 times 3, which is a 6, which is it. We're done. Nice job. Looking at problem number 5. Now we get to problem number 5. We get a square root of 128. You come over there, you got to break this down. So you get 64 and 2. You get 8 and 8. You get 4 and 2. You get 2 and 2. Breaking down the other 8, you get 4 and 2 and 2 and 2. So looking at all of our ending branches, these are where our branches all came to an end. They stop at a prime number. We can rewrite 128 as 7 2's. 2, 2, 2, 2, 2, 2, 2. Pull out your 2-for-1s. 1, 2, 2, 2, 3 2's being pulled out of there. These all go away. 2 times 2 times 2 is 8 square roots of 2, and we are all done. Nice job. Let's looking at number 7. Looking at problem number 7, here we go. We got 216. We need to break this down. So divide it by 2 since it's an even number. We know that this will work. We get 108. Taking 108 and dividing that by 2, we get 56. 56 is going to be 8 times 7. 7 is a prime number. 8 is not, though, so let's break that down. 4 and 2. And then 2 and 2. So we get, looks like 5 2's and a 7. So coming on over, we get 2, 2, 2, 2, 2, and a 7. Now, do your 2-for-1 special. 2 of the same, pull one out. 2 of the same, pull one out. Excuse me. It looks like we're pulling out two groups of 2s, so I'm going to have a 2 and a 2 on the outside. Remember, that's not 22. 2 times 7 on the inside gets us back to 14. Multiplying those out, 2 times 2 is 4. Square roots of 14, and you are done. Nice job. Let's look at number 9 here for a second. Looking at problem number 9. What we're going to want to do is we want to first break down 27. That's going to break into 9 and 3. 9 is just 3 and 3. So 27 is just 3 3's. And then don't forget, we have 3 x's. So when we rewrite this, we are going to come over here. We're going to have a 3. We're going to have a 3. We're going to have a 3. We're going to have an x, and an x. Look for those pairs. 2 3's means we can pull one out. 2 x's means we can pull one out. These go away, go away. I'm going to be left with 3x square roots of 3x. Nice job. Right, so this is all just that basic simplifying skill, and that basic simplifying skill runs through all of these problems that we do, whether we're adding, subtracting, multiplying, or rationalizing the denominator. So it looks like we got one more of those, and then we'll get into some adding, and we'll call it a day. So coming on over here, 5 square roots of 63. What we want to do is break down 63. We're going to break that into 9 and 3. 9 is going to break into 9 and 3. That's not right. 9 and 7. 9 is going to break into 3 and 3. Now, when you come over here, notice this one already has a 5 on the outside. So I'm going to have my 5 there, and then I'm going to have my 3, and my 7. Now, I pull out 2 3s. Notice there's already a 5 out there. So this 3 is going to come out here, and we're going to have to combine these together. It doesn't turn into 53. 5 times 3 is 15. And then I'm going to be left with the square root of 7. Nice job. Now we get to the adding problems. And the thing to remember about the adding problems is that adding radicals is really easy if you have something we call like radicals. Some people like to call them like terms. Even though that's not exactly correct, I definitely see where they are coming from when they say it. Now, in this situation, if you look at number 13, some students would say that these have like terms. And the reason they say that is because they have this idea of what is a like radical. Now, a like radical is when you have two radicals that have the same number underneath. So coming over here, if I had 11 square roots of 7 and I added 7 square roots of 7, I get 18 square roots of 7. Just like when you're adding like terms, we don't change that square root of 7 in this problem. We keep that the same. The only thing that's going to change is the outside number. Taking a look over here at number 15 for a second. Let's break this one down. So we have the square root of 18 minus 4 square roots of 2. Right away, you should notice these do not have like radicals. But just like in every problem we do, we should always try to simplify if possible. So 18 is probably going to get smaller. It would turn into 9 and 2, which is 3 and 3. So rewriting 18, I would write it as 3, 3, 2. And of course, I have a pair of 3's, so we can pull that out. So the square root of 18 is really just 3 square roots of 2. Now let's drop everything else on down. We're going to have minus 4 square roots of 2. So if I have 3 square roots of 2 and I take away 4 square roots of 2, I'm going to be left with a negative 1 square root of 2. Nice job. Looking over here at problem number 17, our second to last one. Looks like in this situation, both of our radicals can be broken down and simplified. So let's do that right off the bat. 45 is 9 and 5. 9 is 3 and 3. So I can rewrite 4 square roots of 45 as 4 times 3 times 3 times 5. Now simplifying 2 square roots of 500, this would be 5 and 100 is 10 and 10. So I'm going to get 2. Oh, actually 10 is 2 and 5 and 2 and 5. So I'm going to keep my 2 on the outside, and then I'm going to have 2, 2, and it looks like we have 3 5s over here. So 2, 2, 5, 5, 5. Since this was being added, we'll put a plus in between. Now let's go through and simplify those. So coming on over, you got 2 3's, you pull 1 out. 4 times 3 is 12 square roots of 5. Over on the other side, you got 2 2's, you're going to pull out a 2. You got 2 5's, you're going to pull out a 5. So we have a 2 and a 5 on the outside. You're going to be left with the square root of 5. Now over here, we had a 2, and a 5 that were able to be pulled out. So what we want to do is multiply those together. 2 times 2 is 4. 4 times 5 is 20. So this is really 20 on the outside. We'll put the plus in between again. Now, if you notice in this situation, we ended up with like radicals. That is great. So take those like radicals. Let's add them together. If I have 12 square roots of 5 plus 20 square roots of 5, I'm going to get 32 square roots of 5. Nice job. Last problem, number 19. We're going to treat it the same way. We're going to break down everything first, and if we can, we're going to combine them at the end. So 90 is 45 and 2. 45 is 9 and 5. 9 is 3 and 3. Let's break down 160 while we're here, too. It looks like that would be 2 and 80, which would be 2 and 40, which would be 2 and 20, which would be 2 and 10, which would be 2 and 5. So when I rewrite these, let's just actually simplify this. So 7 square roots of 90 can be rewritten as 2, 3, 3, 5. 2, 3, 3, 5. So we can pull out a 3, which is going to make that 7 times 3, which is 21 on the outside. And then we have a 2 and a 5 that were left here, which are going to make 10. For 60, maybe let's not even try to rewrite it. Looks like I'm going to be able to pull out a 2. And another 2 to the outside. That means I'm going to have a 4 on the outside. And then I had a 2 and a 5 that were left, so let's keep those on the inside, like so. In this situation, we got like radicals, so let's sit there and combine them. 21 square roots of 10, take away 4 square roots of 10. The lights in my room just turned off. Are going to give us 17 square roots of 10, just like that, kids. Nice job. Your goal today is to go through and finish the rest of the problems. Practice this review. We're going to be building on these skills tomorrow. Thanks, guys. Have a great day.